What drives mantle plumes? And the simple answer is buoyancy. This is a cross-section through the mantle and the earth. And in the centre of the earth, or towards the centre of the earth, is the core, the iron-nickel core. And it is 1,000 degrees hotter than the overlying mantle. Heat conducted from the core into the overlying mantle, into the boundary layer above the core, which is about 100 kilometres thick, lowers the density of the material in that boundary layer. And that boundary layer starts to rise. But before it can rise at an appreciable rate, it has to acquire enough buoyancy to overcome the viscosity of the overlying mantle, which is cold and therefore much stiffer. So in order to do that, a new plume has to have a head, and that head has enough buoyancy to overcome the viscosity of the overlying mantle. And the reason that it has to have a head is the main factor driving buoyancy isn't the density difference. The density difference decides which way the plume is going to go, but the size of the plume. The density difference is raised to the power 1 in the ascent equation, whereas the size of the plume is squared. So it's the size or the diameter of the plume which is the more important term. So a plume has to get a certain diameter before it can start to rise. This is what a new plume looks like. Notice that it has a head which is larger than the tail. The head, as I have said, has to acquire enough buoyancy in order to displace the stiff, cold, overlying mantle with a high viscosity. The tail of the plume, on the other hand, is hotter, and it's rising through its own low viscosity pathway. So the tail of the plume rises faster than the head. So material flows from the hot boundary layer above the core through the tail up to the top of the head. When it reaches the stagnation point at the top of the head, it flows to both sides, giving a spiral motion, and that gives the plume head its characteristic donut shape. As the plume head rises, it grows. You can see that the plume head we're seeing in the second slide is much bigger than in the previous slide, and it grows for two reasons. Firstly, because material in the plume head is rising up its own low viscosity pathway, so it rises faster than the plume head, which has to displace cold, stiff, overlying mantle. So material is constantly being fed up the tail of the plume into the plume head. It also grows because of entrainment. The material in the tail and in the plume head is hotter than the surrounding mantle. It heats by conduction the boundary layer that surrounds the plume head and goes up both sides of the plume tail. When the temperature in the boundary layer around the plume head and the plume tail becomes much the same as the plume, the boundary layer effectively becomes part of the plume and it gets incorporated into the plume head. Near the plume tail, it gets dragged into the bottom of the plume head, and around the plume head, the material that is being spiraled by the circular motion of the plume head gets also drawn into the bottom of the plume head. So the plume head grows from a diameter of about 200 kilometres when it leaves the core mantle boundary to about 1,000 kilometres when it reaches the top of the mantle. When it reaches the top of the mantle, it encounters the stiff boundary layer, the lithosphere at the top of the mantle. And this slows the rate of ascent of the top of the plume. But the bottom plume doesn't feel this, and it continues to rise. As a consequence, the plume head begins to flatten, and it flattens until it forms a disc that is about twice the diameter of the plume head. The plume head had a diameter of 1,000 kilometres before it started to flatten. Once it flattens, it doubles in size, so the diameter of the disc is 2,000 kilometres. And if we go back to the deckhand traps, you can see that the deckhand traps covers an area that is about 2,000 kilometres across. The plume tail, which connects Réunion Island to the Seychelles and goes from the deckhand traps down towards the spreading centre, is produced by the tail of the plume. So the tail of the plume has a much smaller diameter than the head, so the chain of volcanoes is much thinner than the diameter of the flood basalt.